Thanks for hanging around. I guess it's not too late. I should have done some research on AppSync prior to my presentation, because I was also thinking as I was doing this, I could also do a talk maybe on some GraphQL basics, because that was some experience I had earlier in the year. But as it turns out, this presentation, tonight's unofficially like the API night, because I'm talking about OpenAPI, or as I just added to the bottom of this slide, Swagger 3.0. It's known as Swagger, but it's not Swagger anymore. And as I'll get to in a sec, this is sort of defining RESTful APIs as opposed to GraphQL, which for anyone who's done RESTful APIs, there's a shift there. It's like, where's my HTTP status code? But it's a cousin talk, because I'm talking about taking a spec, which GraphQL kind of helps you build itself, and generating source code from. So it's a very similar concept. All right, so this isn't green fields, but imagine green fields as green trees. You start a new project, or you join a new team, or sort of something new is happening. What do you need to know to get started? You're a mobile app developer, a web front-end developer. You're developing something that needs to talk to an API. What do you need to know? Even if you're developing the API yourself, or working with someone who's developing the API, what do you need to know? What do you think about, like, where's my endpoint? What's the structure of the call? How do I authenticate with this API? Is it JSON? I actually don't think people ask that question anymore. It kind of hits them when it's not JSON, if it's not JSON. But you ask these sort of questions asking, well, are there any API docs? The answer often is no. Often the documentation is the most recent iOS implementation. What's the endpoint? Where do I start? Where's the .com/v1 whatever? How do I authenticate? Is it tokens? Is it OAuth? What is OAuth? That's a different talk. Should I trust this response? This API is returning this data, but how do I know that that's right? And what does 418 mean? I'm getting a 418 in this case. If you look it up, it's a teapot, but that can mean anything. It's like this. You arrive at a new project, and what I'm pitching to you today, apart from the IKEA passion I have, is the API, or OpenAPI, or Swagger, is that kind of answer. It helps you answer those questions. Now, there's a caveat to that, because if there's no API spec, it doesn't answer any questions. You've got to write it yourself. But by virtue of trying to create the spec, you'll answer the questions along the way. So tonight's presentation is kind of, what is OpenAPI? And the first answer to that question is it's Swagger. Has anyone heard of Swagger? Prior to me mentioning this is Swagger, did you know that OpenAPI was Swagger? Yeah, okay, enough people, not 3, 4 people. When we're going to talk about sort of defining a schema, I'm going to go over a really simple example. Then I'm going to go over some OpenAPI CodeGen, which is a project that has been, what I'm talking about has been forked from the original Swagger CodeGen. And then I've got some extra content. If you like the Hydraulic Press channel YouTube channel, they always have extra content at the end, and that's exactly what I'm referencing. So what is OpenAPI? It's basically a standard language agnostic interface to RESTful APIs. So it's the cousin to GraphQL. The TLDR is it's a YAML file that defines your API endpoints. And it defines the response, it defines how you would send a request to it, and how you would authenticate with it. That's basically it. So instead of handwriting a README file, which we're all doing, and I did last week, this is a standard for defining a RESTful API. The Swagger def for a GraphQL API would be about 5 lines long. It's for RESTful APIs. It's designed specifically for that, and you'll see that in a second. Now, things you can do with an API spec once you've got one, and this applies to GraphQL as well. Once you've got a spec, if the spec's any good, you can generate API documentation from that. because itself is just a YAML file or a JSON file. You can generate your docs. You can generate client implementations, so that would be the code you run on your phone or your mobile device or your front end or your JavaScript app. You can generate server implementations, and the server implementation would be that kind of last mile of transformation out to JSON. You can also, and to extend on that, a more complex use case would be to validate the API response. So what the Swagger def or the OpenAPI definition says is the response should look like this. Through some of the tooling that's open source and available, and even it's quite simple to write your own, you can validate that response. And we're getting a lot of business value and time saving out of being able to validate responses. You can also build, by validating responses extends to building automated tests around a third-party API or your own API. And I'm not talking about writing unit tests in your API code. I'm talking either that or external tests. A little bit of background, as I've referenced. OpenAPI is open source under this OpenAPI initiative project. It's got all the big names attached to it. Version 3.0 has been around for just over 12 months. And 2.0 was the one that was previously known as Swagger. So although Swagger has become OpenAPI, Swagger is sort of what was called a 2.0. And nowadays it's all OpenAPI, and the Swagger is the Smart Bear company's kind of brand name for their tools around Swagger. And my point here is it's essentially a superset of JSON schema, and I'll talk about JSON schema in the next few slides. Why am I talking about this again? I'm conscious that I spoke about this 12 months ago, or a little 18 months ago. It might be fresh to some of you, which is good. But the reason I thought I'd talk about it again, and I even used the same pretty trees that I took. And t-shirt. Yeah. I am consistent. The reason I'm talking about this again is because when I spoke about this last year, it was a Swagger 2.0 project. And anyone who's kind of worked closely with me on these projects knows that the tooling around Swagger 2.0 was quite frustrating and poor, and it never really felt like it was doing what I, in my head, wanted it to do. More recently, I had a new project come up where I thought, oh, I'll try 3.0, and immediately my kind of issues with 2.0 are gone. So I'm talking about it again because 3.0 is worth talking about relative to 2.0. So anyone who's used 2.0, it's worth looking at 3.0. And that's what I just said. The tools have caught up. V2 had a lot of limitations, and because it's a superset of JSON schema, at the same time 2.0 came out, JSON schema was moving forward too. The tools just weren't lined up. Now that 3.0's out, JSON schema's stabilized, and all the tooling seems to be really nice and up to scratch. So I want to go through the rest of this presentation with a bit of an example project. I'm going to try and flick between slides, but basically what I've done is I extended the little app that I wrote last year, Melbourne CocoaHeads events. I added an app icon, I updated it to Swift 4 or 4.2, and I regenerated the API. I also updated the API because might as well do everything, fixed a few typos in the website at the same time. It's been a very busy weekend, long weekend. So I'll go through, well, basically this little app that I've got, just to get a picture in your mind, or the same picture in your mind. Hold on. Turn off. Hold on. So I built a little iOS app, and it talks to the Melbourne CocoaHeads events API. Very simple. But you can go to the events, you can refresh it. It must be ordered by the end date because tonight is still appearing. I thought that might disappear after 6:30. And yeah, you just tap through and it uses a URL that's part of the JSON package to then just load the web page. It's very simple. So you can see, I mean, there's nothing special about that. So what this is doing is it's got a code-generated API project in there, and it's hitting the endpoint. To show you the endpoint, if you go to, if you get CocoaHeads.com, melbournecocoaheads.com/events, or /API/events, you get back this relatively benign JSON document back. So it's just data with an array of events. So that's the reference point for this. They have standard things like self-links that link back to themselves, on the web links that the app's using. It's all stuff that was already there in the database. So I will go back to DexSet. This is your standard events response from our API. As I just said, I've condensed it slightly. It's not pretty printed as much as it could be. I've condensed it to fit on the slide. But the idea is the response has a data object, a links object, and then a list of event objects. This is what an OpenAPI spec for that response would look like. And I'm just going to run through it really briefly. This is an abbreviated top section of the whole document. You start off with the kind of metadata at the top, the version, the info, the servers. There's your first point. That's where you start. You can have multiple URLs, but that's where you start there. And then it could just be me. It makes sense to me that the next element is paths, and you can just read down the screen. You've got events. So that's literally /API/events. I'm going to send it a GET request, and I'm expecting a response 200 content application JSON. That's the response type, and then I've got a schema. So when I said before that it's a superset of JSON schema, the schema objects are JSON schema objects. So this is the core of the Swagger OpenAPI stuff. You just define the HTTP verb, the response code, and the content type. And it works the other direction as well. So if you're, say, doing a post, you can also define the query type, or you get request, you can do the query, but in a post request, you can also do the body of the request as well. So OpenAPI lets you, and if you look at the comparison between 2.0 and 3.0, this is much more organized. OpenAPI lets you define these kind of elements, and you've already just seen info, server, and paths. Down in components, it's just a list of schemas that you can reuse through the app. So for example, components, you could define responses, parameters, examples. I'll show you a couple of those. It all starts to repeat itself. These documents get quite long. But where does JSON schema fit? Most of the elements that aren't those first few things are JSON schemas. And schema objects themselves are defined by JSON schema. And it's basically a vocab. Again, it's another specification. But it basically lets you define a JSON document. So if you've got a JSON blob or a JSON object, you can write a JSON schema that you can then use to validate it. For example, this is a cut down event. This is as cut down as you can go. The title, the description, and the start date. 3 key values. One of them is a date, an ISO 8601. The other 2 are strings. This would be the JSON schema in YAML. So we're already crossing a few boundaries here, but it looks nicer in YAML. This is the JSON schema representation for 3 keys, 3 values, 1 is a date. So you've got the type of the object is the type of it is an object, and these are the properties that it has, the 3 properties, and they're all required. You can see the required thing down the bottom. In the case of the start date, there's no type of date in JSON. So the JSON schema allows you to extend it to say the type is a string, so it's literally a string, but the format of that string is a date time. And again, that format, there's all sorts of, you can add all sorts of logic to these things, because if you look into it, the JSON schema itself is incredibly powerful. It has its own set of tools, validators, parsers, generators. This AJV project is an abbreviation for another JSON schema validator, and on its README page, it's like benchmarking itself against all the other JSON schema validators. Like it's a real thing. But schemas aren't just. I can see my own spelling mistake there. Schemes allow references, reuse, and composition. So if you've got a part of a schema that references other things, it's got all that built into it. It's limited to some extent to what you can represent in JSON, but for our APIs that we deal with, it's perfect. So yeah, it can't define HTTP. Like it's sort of just response type. So therefore, that's where OpenAPI comes in. So where have we got here? If we go back to what we looked at before, now the schema object that comes back from our API events GET request starts to look a bit more like JSON schema. So you can see here that I've got my type, the response comes back as an object. I think most JSON responses should be an object anyway. And it has a data object and a links object. Data is of type array, and the items in the array are of type this reference. It's referencing somewhere else in the schema. And that's further along, that's down in the components section. If I scroll up, the component section of this schema looks like event with all the event properties. And it's very clearly, in a simple sense, starting to reference back onto itself. The same things start repeating. Once you get your head into this, you can type out a schema really quickly. And if you use the tool and the extra content to check your spelling and make sure it's all good, it's pretty straightforward. So now that you've got a schema for your very simple API, we can use that and generate some pretty modern Swift code with it. 12 months ago, I'm probably going to get to this anyway. The schema for the Melbourne CocoaHeads website is published on GitHub. This is what I was doing on the weekend, publishing, where is it? It's one of these tabs. Nope. Nope. Okay, I got the API client. Okay, it's just here. Website. Security vulnerabilities, oops. Where is it? It's schema, OpenAPI. So just included in the directory of their website is just that schema I showed you. So it's just a YAML file with all the details. There's a few extra elements there where you can add examples and other things which will come useful in a minute. And what you can do with that schema is, well, obviously because it's a Magic PHP project, it's published online as a JSON file. Now that that's publicly available, you can use this OpenAPI generator tool to generate a Swift client from it. So you can brew install OpenAPI generator. It's this Java thing that I just tried. The brew is not in its setup instructions. I tried it and it works and it's there and it's a modern version. So I don't know how to run Java apps otherwise. Swift format is also recommended to install with it as well. It's actually a really good idea because it generates it and then you can cut out all the extra white space and bits that you've got there. So it's actually great. So you take OpenAPI generator. The generator is Swift 4. It also supports Swift 3 and Swift 2 for now, for just legacy's sake. You can give it an output directory or use the current directory, so it'll just put it where you are now or in a directory. And you give it you just point to the API or the OpenAPI JSON file. Then you pipe it through Swift format and trim the white space, and you've actually got everything you need. Now what's really interesting is what it does, and compared to 12 months ago, it's actually really, really good. It generates a CocoaPod, like Carthage compatible framework. So it just dumps everything into the folder you tell it. It's got a pod spec, a Carthage cart file, a couple of other dot files that you can play with. Since Swift 4.2, the models are value types. That wasn't the case last year. It utilizes Codable. That wasn't the case last year. It's type safe in the sense that your your required fields that you specify in your API spec come as required objects, or non-optionals. It has a type for dates. So everything that the API I wrote there, it comes back as Swift types, as I expect. There's a few customizable options that you can tell it to not override certain files if you change them. For example, I changed the built-in version. The problem with it is its dependency on LMFI. If I was thinking of contributing something to this, you'd just write a stock one. You wouldn't make it depend on LMFI. But I changed, locally on my version, I changed the version of LMFI that it points to. It seemed to work. So I was pretty impressed with what it came up with. Now, we could dig into the code, but the point is, and as I discovered, and if you look through the Git history, I discovered it very late on Tuesday night, it generates this dependency. And I was ready to just take the code that it generated and slurp it into my app. But what it actually created was a fully functional CocoaPod. So you just, well, what I did is just commit that to an extra Git repo and then depend on that in my other app. I was pretty, I'm like, okay, great. I don't have to deal with that code in my main app. It just comes through as the module name that I tell it to, and it's there. I'm not a huge fan of CocoaPods, but it made it very simple. And in the three layers to generated code I wrote here, that's layer 1 or layer 0. That's the generated code. Commit it to a repo over there, include it in your repository, and you can tag that on GitHub and then depend on specific versions as you go. And then just sort of BYO application models and extensions. So there's a few core extensions you might want to add. And an example of an application model is maybe you don't need all the objects you get returned. So you just create your own. And I've got some examples of these layers here. And then BYO view models as well. So you've generated some code. You've pushed it up to GitHub. That's what I had here. So you've got, your organization GitHub / some repo, and it comes out with this folder structure and everything here. These are all the, yes. I'm basically just showing you GitHub. It generates all these files here, but as soon as I realized you can just include it as a CocoaPod, it just doesn't matter anymore. It's like, okay, cool. Because I was really worried about the structure and all this, and I'm like, oh, it makes a folder with APIs and makes a folder with models, and it doesn't matter. Not to dismiss that, but once you include it in your CocoaHeads mobile project that we saw running on the simulator there, this is the pod file. It previously depended on LMFI, now it doesn't have to. It just depends on CocoaHeads API client. And version 1.01, because I think I spelled something wrong, so it's not 1.0. But it demonstrates the point that you can move along as, so the API could be developed, the Swagger YAML or the OpenAPI JSON YAML file could be developed or managed or maintained by your API developers or yourself if you're the API developer. And then your CI system could automatically generate the Swift client, commit it automatically to this repository, and just version it as you go. And as the API developer, the client developer, you just choose when you want to update. That's one idea. Layer 2, once you've included that dependency, you end up with you have to import CocoaHeads API client, and then you end up with all of its classes and accesses. So it creates these inline response objects, so a little bit messy. You can get around that if you change your spec, but I wasn't interested in changing the spec to make the generator look better. So you can do things like this. You can just type alias ugly things to make them nicer. And then you can extend events API, which is that's the core class it gives you with all the methods on it. If you want to, why did I do that? I wanted to create a different response that returned a result type. So I just, because you can just extend things in Swift, you can create your own methods that call into, so get events here calls back into itself, the parent method, I think, and then calls the completion there. So that's one example of extending what they give you. Around the similar layer, or maybe it's a view model layer, it depends on how many M's are in our MVC model. But in my controller, I might have a load events method, and I'd call that method API get events, and then before can I highlight this? No, it's going to go forward. Before I go forward, I'm switching over my result type that I got, and before I call display events, I'm actually taking the event object, the generated event object, and passing it into my own like little list event object that just, it's a bit more of a view model sort of element there. So I guess my point is it's very low touch. I can generate this API client, include it, extend it, and I don't really have to worry about it too much. These two things are up on GitHub, CocoaHeads iOS and API client. They reference each other. They work really simply. I've got some good links here to the OpenAPI specification, OpenAPI tools, the OpenAPI generator, and there's a good README here on the difference between Swagger 2 and Swagger 3. Before I go into my extra content, I will just show you a couple of the models. So I've turned my Xcode up big, and my very simple app, it's got one view controller, or two, one main one, and inside, this is that load events method. Let's get rid of this here. This is load events just here that I just showed in that slide, and it calls into the get events method that I've extended, and that calls into get events on the generated class. And the generated class is quite kind of long, so it comes up with this events API class. And you can see here it generates all the endpoints. It's added, this is an endpoint I didn't show. You can get an individual event, but it adds the comments in that you added in the Swagger definition. It adds the HTTP parameter, all the comments and all the bits and pieces you added in there. It's, there's strings in here that it's not perfect, but you don't have to touch this stuff. And it's backing onto LMOfire as well. So get events is what I wanted to overload, and I just did that in my own extension up here on events API. And the only reason I did that is because I wanted a result type out of LMOfire instead of a standard one. The other extension point that I added was once you map over this result type, you've got response.data, and you compact map the data, because we know from the spec that data is just an array of events. I map that over to this list event type. And list event is just another struct that has a failable initializer, which is super handy, especially because compact map will just get rid of it if it's not valid. You can map over things that, you can fail when you need to fail. So for example, if URLs aren't valid, nothing to this point has done that validation. You can jump in. It does a few things like the keyword description. It's a bit vague in Swiftland, but it handles it by adding an underscore. So they've thought of a lot of things. But my list event is my little value type that my app deals with, and from then on in, I'm not concerned with the generated code at all. It's super tidy. I was pretty impressed. From my experience, I think this would scale to something real as opposed to this. And I'll jump back into my extra content. So extra content, as I mentioned, with the Swagger spec or with the spec like this, you can generate documentation. Now, the JavaScript community have jumped on board with this, and they do websites and CSS and all those things, and that's really handy for documentation. This is all you need to add to use this redoc documentation doodad. You don't have to include it in your project as an NPM dependency. You don't have to have a grunt build task or a whatever it is build task this month. You just include this. It's hitting their CDN, which is great. So what I've done is magic of PHP, included this in a view, and if you go to melbournecocoaheads.com/API, there's no, I've done no code, you end up with some very fancy, at least fancy. I need to convince a few people at work that this is fancy. There's different opinions. You get some documentation based on what you've written. So you can come in here as a developer and you say, okay, what's this API about? Okay, get events. Oh, great, this is what I get with a 200 response. You get the data, it all unfurls as you tap on it. Over on the right-hand side, you've got the different endpoints that might have been defined, and then you've got some example, and I've added the examples myself in the spec, but you've got some examples there of what the data might look like. So if you arrive at a new project, this is super handy. And there's zero work to add this. So Color Me very impressed with that.
So is it just a web page that's taking the swag out there?
Yep. Yep. The first in this here, there's this redoc parameter tag here, which is my JSON file. It does the rest. That's a total win. You could sell that to anybody. Sell that to any business. The second thing might be a bit, people might not like, but in Swagger 2.0 land, you had to, like, one of the better tools was this web editor that would validate your Swagger YAML JSON thing as you wrote it. It was the worst. I tried to get it running locally. Again, it was some Java thing and I couldn't install it with Homebrew. For some reason, I'm like, okay, I'm going to look a bit differently. There is a plugin for Eclipse that will validate your OpenAPI 3, and it reads the top value to know what version you're talking about, and it will give you like red dots and validation errors as you go along. Eclipse is free. This is part of a bigger package this company offers. But for the purpose of writing this spec and some specs I've done at work recently, it's great because you end up with it. The errors are really esoteric. They don't make any sense. Like if there's an error on line 4, it'll hide all the errors after the fact. So it's not. Anyway, you get better at writing it eventually. But yeah, that's. I have it open. I don't think I've got it open at the moment. I had it open today, and it's not too bad.
There is also a plugin for VS Code too, if you don't like it.
Is there?
Yes.
Okay. I should try that one. But the Eclipse was a funny one. So that's all I had prepared. I think if you're interested in this topic, it's something I spend a lot of time advocating for, writing writing client-side scripts to validate using these specs. If you want to talk to me about it later on down the line, something I do a lot. Any questions for now? Happy to field any questions?
Just are you using are you using OpenAPI 3 with a client?
We're using it for the documentation element now, and so we're at an early stage. So we've been contracted to sort of design the spec. Someone else on the other side of the fence is going to build the API, and then we'll consume it. So I'll probably consider the code gen for that once we get a bit further along. But currently, right now, we've got some stuff built on 2.0 that we're using, and then this is out of an experiment to look at 3.0, and all my frustration from 2 was just evaporated. So, yeah. Oliver.
Yeah, it's always comments. Anyway, yeah. So I'll just add on essentially to Jesse's talk here. So we used Swagger at ANZ.
Yep.
So one of the major problems we had there was there was no documentation for a lot of the APIs. They had wiki pages which were badly maintained and so on. And so from the mobile app side, we kind of forced them to give us Swagger at the time 2.0 specifications.
Yep.
And that let us code-gen clients.
You were code-genning?
Yeah, we were using code-gen. We weren't using the LMFI or the generated client, we were just using the model types.
Okay.
So that's another use case. You can just use parts of the generated code. You don't have to use it all. Because it does come in as just a separate framework. The other thing is at AGL we're using Swagger, but not for CodeGen or anything like that, but just as a way of documenting things better. So upfront design, essentially using the OpenAPI YAML spec sort of language to define objects and things and define the APIs or write up architecture documentation.
I find that almost more valuable than any other part is creating that as a conversation point.
Yeah, it lets you get really precise about things, so there's no ambiguity about is this a required parameter or what have you and so on. So yeah, super easy. And I noticed a very good use case in your code there of why you might use a client like this. If your API developer accidentally spells events incorrectly, you don't care. He fixes it, or she fixes it, or they fix it, and then you regenerate your client code and...
Did I spell events wrong?
Yeah, it was when you were showing the generated code. Anyway, doesn't matter. But,
something about events and okay.
Yeah, so your API developer has made a mistake in their spelling of a path and you don't care because your client code is just generated and you carry on.
But if no one cares, does it matter that it's spelled wrong?
Exactly. Yeah. If a tree falls and no one hears a tree fall, does a tree fall? Yeah. Anyway, cool.
I'd actually like to tack on some experience to this one, but not for Swagger or OpenAPI, but just for the JSON schema. Even when I'm defining my data models now for my Swift apps, I'll do it in JSON schema, just because it gets you out of Swift mode and gets you into thinking about components that are reusable. And it's really good for refactoring. Like as Jesse pointed out, the references, refactoring stuff into references for other places without having to spend time fighting with Xcode. So +1 JSON schema.
We've, in a couple of cases as well, we've written tests for an API and we haven't had Swagger, we've just written JSON schemas for the responses. And it's very easy to just do a GET request in any programming, any Python language, PHP, and then just assert that the response equals always validates against the thing. So it's, JSON schema I think is like the hero of everything. Yep.
Does anyone know where the name Swagger came from?
I'm really glad it's not Swagger anymore. I'm glad it's not Swagger anymore. OpenAPI is much more
Professional?
serious. Yeah. Swagger always jarred. It was a bit jarring in my mind. I don't know.
It's not quite the one happening. Like, Swagger was always owned by someone.
Yes. Whereas OpenAPI is open. All right.
Any more questions?
Thank you very much. Awesome. Cheers.